Welcome to Physics Prep. This is a question from TATA-GS 2019, and in it we are told that 500 gram of coffee is present at a temperature, let me write that as Ti, which is the initial temperature, that is 80 degrees centigrades. Assuming that the heat capacity of the liquid, I'll write it as S, is 1 calories per gram per degree centigrade, and the latent heat of fusion for ice. So let me write that latent heat of fusion is 80 calories per gram. The amount of ice that must be dropped into the cup to convert it into cold coffee at 5 degrees centigrades. So the final temperature must be 5 degrees centigrades. What we can see here is that there are two systems. The first one is coffee, which is at the temperature of 80 degrees, and the second system is ice. What the question tells us is that the heat from the coffee must travel into the ice so that this ice comes to 5 degrees centigrade. Let's say it was at 0 degrees centigrade initially. It also reaches 5 degrees centigrade from an initial 80 degrees centigrades. For this process to happen, there is a certain heat required, which is equals to the mass of ice multiplied with the latent heat of ice. This is just enough to melt ice to water, but then we also need to increase to 5 degrees centigrades. So let's write as del T of ice, and this has to be multiplied with the specific heat as well as the mass of ice. And for this process to happen, there is a heat that it needs to give somewhere else so that it can come to a lower temperature. So this must be equals to mass of the coffee times the specific heat multiplied with the change in temperature. And since this is a closed system, Hg must equal Hr, which implies mc as del T must be equals to mi Lh plus S del Ti. What we need to find is mi. So this implies mi equals mc as del T divided by Lh plus S del T of I. Now the mass of coffee was 500 grams times the specific heat is 1, change in temperature is 80 minus 5, that is 75, divided by the latent heat is 80 calories per gram, plus S is again 1 and del Ti is 5 for the ice. So this gives us that the mass of ice is equals to 441 gram, and that is our answer.